Hubbub by the HDB, brought to you by TP03. Typical chest areas are placed at the void decks. Therefore, the sound travels through the ceiling and up into the apartment of residents living above. Furthermore, the wind carries the sound up, thus there are complaints of such rowdy noise. This diagram shows how sound is transmitted when a person speaks in an open area. So when noise is produced due to the people playing chess under the void deck, the direct sound will travel, and after it hits the ceiling, it will turn into reflected sound. When there is too much noise, there will be a buildup of reflected sounds which can be transmitted through the ceiling, thus disrupting the residents living above. Sound can be reflected at different angles after hitting different variation of surfaces: straight, curved, and slanted. Our first idea used the curved surfaces, whereby sound reflects similarly to the lens and light theory, thus sound will be reflected in a parallel motion. Because of this, sound will go back and forth between the walls. We have tested out this theory, and in conclusion, it's not very modular due to its rounded shape, and it does not help in diffusing the sound because the space only contains the sound. We improvised from this idea and took inspiration from how the auditorium works. We continued by researching on how form can diffuse the sound, hence coming out with our final product. Our prototype has a slanted surface, which will redirect sound towards the ceiling and will be absorbed by the fiberglass board, which has a high absorption capacity. This allows very little sound to escape, which will not disrupt the residents. The slanted surface in our prototype is transparent polycarbonate, which is a strong thermoplastic material which is lightweight and can withstand extremely low and high temperatures. The polycarbonate is resistant to heat, sunlight, and rain, which is perfect for Singapore's all-year-round summer season. The treated wood laminate is easy to maintain and add aesthetics to the space. Our ceiling is made out of aluminium panels, which matches the linkways shelter. To reduce noise produced from rain, we will coat the panel with Mega Sober LDS liquid deadener. The underside of the ceiling is installed with sound-absorbing fiberglass board. The window frame steel is coated with grey paint due to ease of construction, low cost, high strength, durability, and sustainability. We are using wood plastic composite WPC decking for the flooring, which has high durability and is resistant to cracks and slips. All these materials will help reduce noise traveling to the HDB flat. So how does our design work? This is the layout plan of our design. Location of chest area is moved to the linkways in between the HDB blocks and bus stops. As the distance from the blocks is increased, there will be lesser noise that will reach our proposed location. Wind path will direct sound in a direction where it does not reach the blocks. Walls of proposed structure will contain soundproofing materials and direct sound away from HDB blocks. Here we have a close-up of our design. Walls are sound-reflective polycarbonate, whereby it will redirect sound towards the ceiling, which blocks the sound path towards the HDB blocks. Ceiling has fiberglass board to further diffuse the sound redirected from the polycarbonate walls and reduce the noise escaping from the structure. Over here shows how the elderly use the space by playing chess, and behind you can see the HDB blocks. Here shows a clear image on where the structure is located, and as you can see, the bus stops are located next to our structure. Here is another image showing that more people can occupy the space to watch chess matches or lounge around. Our structure is also wheelchair accessible as it's connected to the linkways. We hope you enjoyed the video.